Hello guys, welcome back to another video. I trust and hope that you're all doing well and is staying safe. Today, we're going to be looking at forces on flat surface and incline plane. And just a brief introduction to working with forces on flat surface and incline plane. So here I have an object on a flat surface, and this we're going to call it our surface. All right, and here I have my object. Now, this object is going to always be exerting a weight on the surface, right? And we know that weight that is being exerted is always going to be that weight due to gravity, that gravitational pull on the object, right? And we're going to call that mg. Now, the object exerts some force on the surface. Now, that surface is going to exert what we call an opposite force on the object, right? And we're going to call that our normal force, Fn. Now, we know that the force pushing down and that force pushing up, they balances out, right? And that's simple law of physics right there. For every action, there's going to be some equal or opposite reaction, and that would be why we would understand to its fullest extent why the object would not fall through the surface, right? Simple law of physics. Now, let us say there was some force pulling on this object, and we're going to call that Fw. There is going to be some frictional force that is pushing back in the opposite direction, and we're going to call that Fr. Now, when the force pushing down balances out with that force pushing up, so the normal force of this object balances out with the weight, and the force that is pushing the object, so this force that is pushing the object or that is pulling the object towards this direction balances out with that frictional force, then this object will remain static. And we say this object is in this object at this point would be in equilibrium, is not moving, is static. Now, this is always the case for an object that is on flat surface. But what happens when we have an object on an inclined plane? Because we know this is not always the case. What happens when we have an object on an inclined plane? Let us look at this. We have an object on an inclined plane. So here I have my inclined plane. So I have my inclined plane, and there is some object not moving, of course. There is some object on my inclined plane. Now, as was mentioned before, there is always going to be some weight acting down due to gravity, and we're going to refer that as mg. Now, Let us go back to our first diagram. Notice that my forces always acts parallel or perpendicular to my surface. The forces exerted on object always acts parallel or perpendicular to my surface. Now, let us look at this. The normal force of this object must be acting perpendicular to my surface, which means that I cannot draw my normal force going up because this would not be acting perpendicular to my surface. So what I will do is I will have to slant my normal force. And this would be acting perpendicular to my surface. And this is my surface, my incline plane. Now, we know that the mere fact that this object is not moving, there is an equal force being exerted in the opposite direction. Sorry. There's going to be some equal force being exerted in the opposite direction. Let me just quickly fix this up a little. So there's going to be some equal force being exerted in the opposite direction. Right? So let's call this Y. Let's call this force Y. Now, on this inclined plane, let us say there is some force pulling on the object. There is some force pulling on the object in a downward motion, and we're going to call that FW. And we know that there is the mere fact that the object is not moving, there is some opposite force that is pushing back on the object in the opposite direction. And that's going to be the force of friction. We can call this FR. Now, look at the force that acts. Remember now that the force that is acting on this object, in order for it to be in equilibrium, must be parallel or perpendicular to the surface that the object is on. Now, what if I want to find my normal force? Or what if I want to find the force that is pushing on the object, or my frictional force? Well, first, the mere fact that this object is static, is not moving, the mere fact that it is not moving is going to indicate to us that the force that is acting up is going to be equal to the force acting down perpendicular to my surface. So my normal force is going to be equal to Y, the force acting down perpendicular to my to my to my surface. Now, if I should connect my line here, this become a right angle triangle, and we're going to call this X. Let's call this X. Naturally, there's going to be some angle here, theta. Now, if this angle is theta, this is going to be 90. Then the angle here, this angle here, naturally is going to be, all angles must add up to 180. So 90 plus theta, and we're subtracting 90 plus theta from 180. So it's going to be 180 minus 90 plus theta. Right? So this is going to be 180 minus 90 plus theta. Now, this within itself is a right angle, right? Right here, we have that right angle, right? If we should go here, we're going to have a right angle here, and it's not very large. I can take out a simple sketch of it so that you can see. You will have that understanding really of what it is that I am talking about here, right? So you're going to have that here with this being 90, of course. Now, if you should look here, what it is that I have here. So this is my right angle triangle right here that I'm working with. So I'm just pulling it out. This being 90. Noticed that I have an alternate angle here. I have an alternate angle here. So whatever this is, we know that is going to have you know, that same angle. And I'm not going to get too much into it, but this angle here would be equal to theta, right? And I'm going to ask you to, of course, go ahead and show us, with your full-on explanation what just took place. Here you can do your homework on it. In the next video, we're going to explain it in its entirety. So this angle here is going to be theta. Now, with this angle being theta, we want to find the normal force. And we established that the force going up is always equal to the force going down, that is perpendicular to the surface of that object, given that the object is not moving. All right? So right here, we can say, and we're going to use up some simple trigonometry here. If I want to find my y, my force acting down here, using, and that's why, using my simple trigonometric ratio, here I have my weight, which is my hypotenuse, and I have my adjacent. I have my hypotenuse and I have my adjacent. So the cosine of my angle theta is going to be equal to my adjacent, which is y, over my hypotenuse, which is my weight, mg. Hence, y is going to be equal to mg cos theta. And once we're able to find y, it should be a little more easier for us as sorry, my normal force is going to be that same thing that's happening, because they're going in equal. So they are equal but opposing forces, and that is why the object is said to be in, is not moving, right? It's in equilibrium here. How about my force acting down? So I don't know my force acting down, but notice that the force acting down is equal to this line here. They are parallel and equal. So if I can find the force acting on this line here, it is automatically going to be equal to the force pulling down parallel to the surface on the object. So again, and we are going back to our simple trigonometry here. I have my hypotenuse and my opposite. So sine of my angle theta is going to equal to x, which is my opposite, over my hypotenuse, which is the weight acting down on the object due to gravity. Now, if I want to find x, which is the force acting here, then x is going to be equal to mg sine theta. And we know that the force acting on x here is parallel to the force pulling down on the object. So Fw is going to be mg sine theta. Right? Now, the mere fact that the object is not moving, it means that the forces along parallel to the surface here, they're equal but opposing force. So, based on Newton's law, the force pulling down plus the frictional force should give me 0. So, if my force that is pulling down is mg sine theta, whatever my frictional force is, I should get 0. Hence, my frictional force, Fr, is going to be equal to negative mg sine theta. Here, I am able to find my force due to friction. I am able to find the force pulling down on my object. And I am able to find my normal force. I'm able to find my normal force. And we, in real world, generally we're driving, we're pushing a wheelchair up an incline plane, or whatever the case is, we use this concept, and in our next video, we're going to look at an example of how we actually use the concept of forces on an inclined plane.